relative frequency. So under this, we shall examine experiments whose results we cannot predict in advance. Such experiments are usually called random experiments. For example, if we toss a fair coin, we may not be able to say for sure whether the coin will land with the head up or with the tail up. Similarly, if we are sure it will land, but we are not sure which of the 6 faces will show up. So this experiment of tossing a fair coin or a fair die, examples of random experiments. So that's why some people say that probability is a branch of mathematics that's dealing with random experiments. Now let's come back here. Suppose we toss a fair coin 100 times. If we denote the number of times we are successful in getting a head showing up by n of s, that is number of success, and we denote the number of trials by n of t, number of trials. Now the ratio number of success over number of trials is called what? Relative frequency of the number of times a head shows up. Exactly. So this is what we call the relative frequency of the number of times a head shows up. Exactly. Now, another concept here is sample space. So it's the set of all possible outcomes of any random experiment, and it will be denoted by S. So another one is an event space, a subset of sample space, which may be a collection of outcomes of a random experiment, is called event space and denoted by E. Is denoted by E. Now, so the probability of an event denoted by PR of E, that is probability of an event, is defined as probability of event is equal to number of events, event space, over number of sample space. So the probability of any event E is a number which satisfies the inequality is 0 less or equal to probability of events less or equal to 1. So this is 0 is the probability of an impossible event, while this 1 is the probability of an event which is certain to occur. Exactly. So the probability will be between 0 and 1. So something that is certain that will not occur, that is impossible events, the probability will be 0, and then something that is certain to occur, the probability will be 1. All other ones will be in between 0 and 1. Now let's quickly look at this first example here. If here dies with 6 faces numbered 1, 2, 3, 4 is tossed twice. A. Obtain all possible outcomes of the magnitude of difference between the numbers showing. Then B. What is the most likely difference and its probability? C. What is the probability of difference of 2? Then D. Find the mean difference. So if you look at this question carefully, so they say that if a dice with 6 faces numbered 1 to 6 is tossed twice, so we have to find the magnitude of difference. So magnitude of the difference will be, for example, now if you say 1 minus 1, that one is 0. 1 minus 2 will be minus 1. A magnitude of minus 1. If you find the modulus of minus 1, you still get 1. So let's see how the table will look like. Now this will be the sample space. So this is the first toss. This is the second one. Is that okay? So we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 as well. Now let's look at, so if you say 1 minus 1 is 0, 1 minus 2 is minus 1, magnitude of minus 1 is 1, 1 minus 3 is minus 2, magnitude of minus 2 will be 2. So everything we'll be getting here will be just be positive, don't worry. So 1 minus 4, 3, 1 minus 5, 4, 1 minus 6, 5. Exactly. So 2 minus 1, 1, 2 minus 2 is 0, 2 minus 3, You know it's minus 1, and magnitude of minus 1, so is equal to 1, that is modulus of minus 1. So everything you'll be getting here will be positive. Don't worry yourself. So if you come to the last one, 6 minus 1, 5, 6 minus 2, 4, 6 minus 3, 3, 6 minus 4, 2, 6 minus 5, 1, then 6 minus 6 is equal to 0. So this is the sample space. Exactly. Now the second question now is, which one is the most likely difference? Which one appears most? So let's check. So this is a 0. Let's start from 0. 0 appears how many times? 1, 2, 3, 4, 5, 6. 6 times. What about 1? 1 appears how many times? 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. So 1 appears. What about 2? What about 2? 1, 2, 3, 4, 5, 6, 7, 8. So 2 appears 8 times. What about 3? 1, 2, 3, 4, 5. 5 times. So it's like 1 is the most likely, the most likely difference is 1. Is that clear? Now, and we have to find the probability. So let E1 be the event space for the most likely difference. The most likely difference is what? Is 1. So let S be the sample space. Then of sample space is equal to 36. If you count from here, 1, 2, 3, 4, 5, 6. So in short, just multiply 6 multiplied by 6 will give you 36. That will be total outcomes. Is that okay? The number of events. This number of events, that is this most likely something is equal to 10, because 1 appears most 10 times. So you have the probability will now be number of events, which is the collection of this one, so which is 10 over 36. So 10 divided by 36 is equal to 2 in 10, 5. 2 in 36 is equal to 18. Is that clear? Now, so this is question A, this is question B. Now let's go to question C. So question C, they say that what is the difference of probability of difference of 2? So let E2 be the event space for a difference of 2. So n of E2 is equal to, so when you count, has already 2 has been counted to be to appear how many times? 8 times. When you check the table, 2 appears 8 times. So the probability of events 2 to occur is n of 2 over sample space, so which is 8 over 36. 8 over 36 is 4 in 8, 2, 4 in 36, 9. Is that clear? Then we are asked to find the mean difference. So let S be the sum of all magnitude of differences. Then adding along the row, so row 1, if you sum up row 1, you will get 15. Row 2 will give you 11. Summation of row 3 will give you 9. Summation of row 4 will give you 9. Summation of row 5 will give you 11. Then summation of row 6 will give you 15. So if you sum up everything, then you will get 70. Is that okay? 70. Now let the mean difference, let D be the mean difference. Then D is equal to S over number of sample space. So S is the sum of all the outcomes now. So we are having 70 over 36. So all the outcomes now, the addition is 70. Is that okay? 70 over sample space, which is 36. Is that okay? So 70 divided by 36 is 1.94. So this is now the mean difference.